Okay, in this video, we are going to solve this limit problem right here, and so let's begin. Now, before we even solve this problem, it's important to understand, piecewise functions and absolute values. So let's say we had the absolute value of x. Now, the absolute value of x, let's say x is 5. Absolute value of 5 is 5. Let's say absolute value of negative 5. If you have a negative 5 here, the absolute value of negative 5 is also 5. And so the way we can write this as a piecewise function is to say that x, when x is greater than or equal to 0, or you could say negative x when x is less than 0. I'll explain why this is. So this right here is equivalent to these two statements, because if x is like a bigger number than 0, let's say 5, absolute value of 5 is 5. If x is 5, you get 5. Let's try 0. If absolute value of 0 is 0, if you put a 0, you also get a 0. Now, it gets different when you have a negative value. Let's say x is negative 3. The absolute value of negative 3 is 3. Now, this version also works because here you have a negative on the outside. So negative 3 is also 3. And so that's why these are equivalent. And for this problem, it's going to be useful because we have the limit as x approaches 3. So at 3, you get 3 minus 3, you get 0. That's a red flag. Now, if you have a bigger number than 3, let's say 3.1, you get 3.1 minus 3, which you get 0.1. Now, if you had a number less than 3, like 2.9, you get 2.9 minus 3, you get negative 0.1. And so the way we're going to do this problem is to split it up. So one version, we're going to say the limit of x approaching 3 less than. Then we're going to say parentheses, instead of saying absolute value of x minus 3, I'm going to change it to negative parentheses x minus 3 divided by x minus 3. And off to the side, I can say when x is less than 3. And now I'm going to do the exact same thing for when limit x approaches greater than 3. So we can say limit x approaches 3 greater than, and instead it's just going to be x minus 3, regular parentheses, divided by x minus 3. And off to the side, you could say when x is greater than or equal to 3. Actually, one more thing. I always like to plug in directly at first. So let's just show that too. I always do it, all my videos. I've always been doing that. So let's try plugging in 3. Here you get 3 minus 3, which is 0. And 3 minus 3, you get 0. 0 divided by 0 means you have to approach this problem differently. And that's why we're doing all of this stuff. Okay, let's see what we get. So x minus 3 divided by x minus 3, they cancel, and you just get, for this piece, would just be a 1. Now this is very similar, same, x minus 3 cancels with this x minus 3, but you have a negative in the front, so this piece becomes a negative 1 as an answer. Now, if you notice, the limit as x approaches 3 less than and the limit as x approaches 3 greater than, they're different values. Therefore, when we state our final limit as x approaches 3, it would have to be does not exist because they're not matching. This is negative 1, this is 1. They're different answers, and because they're different answers, the limit as x approaches 3 would be does not exist. Also, in the description box of this video, there are 2 playlists. One playlist features categorized problems, and the other features random limit problems. And that's pretty much it for this video.